Bismillahir Rahmanir Rahim. We are still in this topic, which is the vector valued function. Last time we spoke about the limit of the vector valued function, and we discussed the continuity of the vector function. Today we are going to speak about the derivative of a vector function. We have scalar function and we have vector function. So the scalar function is just a function that will give me scalar value. It is not a vector value. The derivative for the scalar function is given by the derivative is f prime x equal to 1 over h, or limit of f of x plus h minus f of x. This is the definition of the derivative of a scalar function, provided that the limit exists. If we replace f of x by a vector function, then we will have derivative for the vector valued function. For the vector valued function, r of t. The derivative for the vector valued function given by r prime of t equal the limit of 1 over delta t of r of t plus delta t minus r of t for all t for which the limit exists. So this is the definition of the vector valued function, similar to the definition of the scalar function. So we have to find the derivative of a vector function. It means that we need to find the derivative for each component, which means that if the vector function given by f of t, d of t, and h of t, then the derivative equal to the derivative of the components. Provided that all the components are differentiable. For example, find the derivative of the vector valued function one. So what that r of the vector valued function given by x square, or this is of t, so make it t square len of t and e to power t. And I need to find the derivative for this vector valued function. So the derivative equal to the derivative of the first component, derivative of the second, and derivative of the third component. So the derivative in this case, r prime of t is equal to derivative of t square will give me 2t. Derivative of ln of t equal to 1 over t, and derivative of e to power t is e to power t. Just find the derivative for each component. Second one, so with that r of t is given by x squared, or t again, t squared minus 3t plus 1 I. This is the first component, plus cosine square of t j plus, let's say, t multiplied by e to power 2t. Okay. Now let's find the derivative for this vector function. So the derivative for this one equal to derivative of the first one. This is supposed to be t squared, not t. Is given 2t minus 3 I. This is the derivative of the first component. The derivative of the second component, which is cosine square, that will be plus. We are going to apply the chain rule for the derivative. This is cosine square. The derivative will be 2 cosine of t multiplied by minus sine of t. Apply the chain rule. For the third one, we need to apply the product rule. The product rule for this one, it is f prime g plus g prime f. The derivative of the product of two function equal to f prime g plus g prime f. So the derivative will be derivative of t is equal to 1 multiplied by e to power 2t plus t multiplied by e to t multiplied by the derivative of the power. This is chain rule. All of these be multiplied by the vector k, standard basis. So this is the derivative. It can be written in a nice way. 2t minus 3i minus 2 cosine of t sine j plus e to power 2t plus 2t e to power 2tk. So again, to find the derivative for vector valued function, we have to find the derivative for each component. And we apply all the rules of the scalar function. For each one, I can use the product rule or quotient rule or the chain rule. So this is the idea of finding the vector of, or sorry, the derivative of a vector valued function. We have some rule for the differentiation. say let R1 and R2 be differentiable vector function. And T is scalar or differentiable scalar function. Then number one, the derivative with respect to T of the two vector functions equal to the derivative or the sum of their derivatives. Number two, derivative of the scalar function u of T R1 equal to the derivative of the scalar function. This is the product rule, but we apply it for the vector multiplied by scalar valid function plus number three, the derivative of dot product equal to the derivative of the first one dot the product with the second one plus the first function multiplied by the derivative or dot product with the derivative of the second one. You have to be careful about this one. Derivative of the first one, derivative of the second one, and we apply the dot product. This again dot product, but for the product rule for two vector valued functions, or dot product of two vector valued functions. Number four, for the cross multiplication, d by dt of R1 t cross R2 is equal to the derivative of the first one cross the second one plus first one cross the derivative of the second one. Say, for example, given r1 of t equal to t e to power t and tangent of t. r2 is equal to ln of 2 or ln of t square minus 1 and sine of t. A, or let's say find, still I need one more, say u of t is equal to plus 1. So I have two vector valued function and one scalar function. U of t is a scalar function. So let's find A. I need to find the derivative of this one. U of t scalar function multiplied by the first vector valued function. The derivative is equal to u prime of t multiplied by r1 of t plus u of t multiplied by the derivative of the first valued function. So this is equal to derivative of u of t down is equal to 2t minus 3. This is the derivative of the scalar function multiplied by r1, which is t, e of t tangent, plus u of t as it is will be t square minus 3t plus 1 multiplied by the derivative of r. That will be 1 e t, and derivative of tangent is secant square. Now we have space, I'll write it down, make it smaller. T square minus 3t plus 1 multiplied by derivative is 1 e to power 2 and secant square. So this is the derivative of this one. Scalar multiplied by a scalar valued function multiplied by a vector valued function. Second one is find derivative of r1 t dot product r2 t. For this one, either we will find the dot product first, then we find the derivative, or find the derivative of to the vector valued function and then sum. It is the second or the third one. r1 prime times r2 plus r1 times r2 prime. So we can apply this formula. Is equal to r1 prime dot r2 plus r1 dot r2 prime, which is equal to derivative of the first one is 1 e to power 2t secant square t dot r2 R2 given by len of 2, len of t, and t square minus 1, and sine of t. Plus, now R1 times derivative of R2 or dot product with R2. R1 is t, e to power t, and tangent. Now the derivative of the derivative of R2 is 1 over t, the derivative of len of t equal 1 over t, derivative of t square minus 1, that will be 2t, derivative of sine is cosine of t. This will give me this dot product 1 with len of t equal to len of t plus t square minus 1 multiplied by e to power t plus sine of t multiplied by secant square. This is the first one. Plus t times 1 over t is equal to 1 plus e to power t times 2t is 2t e to power t plus tangent multiplied by cosine is equal to sine of t. So this is the derivative for the dot product. It is a scalar function. It is not a it is not a vector valued function. We can apply the same thing for the cross product, and we need to find R1 prime dot R2 plus or cross product with R2 plus R1 across R2, and then we can find the derivative for a cross multiplication.